Hi everyone, and welcome to another colorful coding tutorial. In this video we will dive into how to create complex sine waves, and how to display these in a circle with polar coordinates. We will also take a look at how to animate the sine waves like the animation you are seeing right now. As always, the source code for this tutorial will be available for my patrons. You can read more about that in the description below. First, let's take a look at how to display a simple sine wave on the canvas. I have already created the canvas and set the background color to some dark shade of gray. So, the easiest way to display the sine wave is by creating a for loop. It should stop when it reaches 359. You will see why in just a moment. Each loop will display a point, and each point will have an x and a y coordinate. In order to make the sine wave go all the way across the screen, we need to map the index of the for loop to the width of the canvas, so when the index is 0, x is also 0, and when the index is 359, x is equal to the width of the canvas. For the y coordinate we can use the sine function. By default, this function takes in a number of radians as an argument. In our case, it would be easier to work with degrees rather than radians. You could manually convert the radians into degrees, but you also have the option to specify the angle mode and set it to degrees, and then this is done automatically. Now we can use the index to pass into the sine function. By default, the sine function only returns values between -1 and 1, but we can scale this up simply by multiplying the function by a higher number, let's say 50. We can now use the x and y coordinates to draw a point for every loop in the for loop. To make it easier to see the points, you might want to change the stroke color to white instead of black, which is the default. Something was drawn on the canvas, but it only seems to be the first half of the sine wave. Fortunately, we can just translate the starting point a bit along the y-axis. Now we can see the full sine wave. In order to change the wavelength, we can simply multiply the sine function's argument by some amount, for instance 2. If you look closely, you can see all the individual points on the sine wave. It would look a bit nicer if the points were connected by a line. We can do that by using the begin shape and end shape functions. Add these on their respective side of the for loop. We also need to change the point to a vertex. As you can see, each wave is filled out with color. You can simply remove that by using the no-fill function. Now, let's draw another sine wave below with another wavelength. Just copy and paste and change the argument of the sine function. Let's use the index without multiplying it. To avoid the two sine waves to be drawn on top of each other, we also need to translate the starting point a bit further down the y-axis. These two sine waves are simple sine waves. We can add these together to a single complex sine wave. Let's see what that would look like. Copy and paste the first sine wave and simply add the two y coordinates together. As you can see, the amplitude of each wave is no longer the same. That is because the amplitude of each point of the two sine waves has been added together. Now that we have seen how adding sine waves together works, let's see how to wrap them like a circle. For this we can use something called polar coordinates. This is a mathematical way to describe a point in a circle, based on a radius and an angle. First, let's get rid of two of the sine waves. We will keep the last one as a starting point for our polar coordinates. To get the idea of how polar coordinates work, let's first just use is to draw a circle. We want the circle to be at the center of the canvas, so use the translate function to place the starting point in the center. Now, we need to specify the radius of the circle. Let's make it 100. When using polar coordinates, the x-coordinate is equal to the radius multiplied by cosine of the angle. and the y-coordinate is equal to the radius multiplied by sine of the angle. The index variable of the for loop still represents this angle. This should be enough to draw a circle. There is a tiny gap between the start and the end of the circle. You can close this gap by using the close argument in the end shape function. Now we can add some sine waves to the circle. Instead of using the sine function with the y-coordinate like before, we now use it with the radius. So, we need to map sine of the index variable, which goes from -1 to 1, to the minimum and maximum length of the radius we want. I'll go with 100 and 200. At first glance, it doesn't look much like a sine wave. That is because, right now there is only wrapped a single sine wave around the circle. Earlier we saw that we could increase the number of sine waves by increasing the value of the argument of the sine function. Let's try that. Now let's add another sine wave to the circle. I will assign each sine wave to a variable to keep the code organized. Now that there is more than one radius, we might have to make them a bit smaller for them to stay within the canvas. Another parameter you can experiment with is the offset in the sine functions. For instance, if you add 90 to one of the sine functions, you can rotate that sine wave by 90 degrees. The last thing I want to cover in this video is how to actually make the sine waves move and make the animation you saw in the start of this video. We are going to use the built-in frame count variable to allow the sine waves to change over time. First, let's create two variables for each of the sine waves. These variables are going to represent the minimum and maximum values of the radius. They should all be mapped to sine of the frame count variable. The output values of the map functions should be somewhere between 0 and 100 in order for the sine waves to stay within the canvas. You can multiply or divide the frame count variable to make the sine waves move faster or slower. You could also add more sine waves if you would like some more complexity. That's it for this video. I hope you were able to follow along all the way. If you want to support my channel, you can join my Patreon, which also gives you access to a lot of free source code from these tutorials, and stuff I upload on Instagram. You can find a link to Patreon in the description below.